In this short video segment, I'm going to talk about fixed effects and the way to implement fixed effects in Stata. So remember, we've seen examples of fixed effects either using a student fixed effect, a school fixed effect, but also use year fixed effects, district fixed effects, state fixed effects, and so forth. In essence, a fixed effect is just a way to limit the variation that we identify off of some subgroup or some category of individuals in your analysis. The advantage of using fixed effects is that it implicitly controls for everything that is fixed about that group. In other words, if I'm using a student fixed effect, where I have observations of a single student over time, a fixed effect for that student takes out anything that is constant or the same about that student across all the time points. Or if, for say, I used a state fixed effect, I would be able to implicitly control for anything that's fixed about that state. So perhaps all of the schools within that state are subject to the same state laws. Well, I'd be able to control for the effect of those state laws using the state fixed effect because those laws apply equally to all schools within the state. So the advantage of a fixed effect is it's an easy way to control for things that we can't necessarily observe, as long as those things are fixed across whatever the units are within that group that we're fixing. Now, I like to visually kind of think of what a fixed effect is doing by looking at a graph. So imagine that we had a series of data points that looked roughly something like this. Now, if I simply asked you to fit a line of best fit or a regression line to this data, you would be wise to show a negatively sloped line, right? The higher the value of the x-axis, the lower the value on the y-axis. And so if this was a regression, you'd infer that there is a negative relationship between these two variables. But if we looked at this data closer, you might notice that there's a certain clustering to the data. In other words, we have a bunch of data points clustered here, a bunch clustered here, and a bunch clustered here. Now imagine that each of these clusters of points perhaps is some unit, such as a school. Well, by using a school fixed effect, we could control for everything that is constant or fixed about that school. And in doing that, we then limit the variation that we identify off of the variation within the school. Then if I asked you to fit a line of best fit, you'd be fitting lines of best fit essentially within each school. Now notice how the data within each school actually has, that's right, a positive slope to it. So by including the school fixed effect, I would find that the relationship between my two variables of interest is actually a positive one rather than a negative one. That red line, or that negative relationship, was simply a product of not controlling for aspects of these schools. But by using a school fixed effect, I was able to control for that and solve that problem. So this kind of visually shows you what a fixed effect might be doing and the value it has in your analysis. Let's jump over to Stata and take a look at how to implement a fixed effect in the Stata environment. So to begin with, we're going back to this data set that we've looked at, which is using data from the ECLSK. So again, I've got students, I've got test scores at the beginning and end of kindergarten, I have indicators for whether the student's race is white or not, and indicators for whether the student has a teacher with a master's degree, a doctorate degree, and so forth. I'll be introducing a new variable here, which is an indicator for the school that the student is in. And that variable is school2ID. Now, one quick little aside that's going to be helpful as you analyze data. The variable school2ID comes in a string format. In other words, it comes as text. But in order to utilize it, we want to go ahead and make it an integer or a numeric format. So I'm going to use a command that's called dstring, which just means to take something from a string or text format to a numeric format. I use the command dstring, the name of the variable, and comma replace to say that I want to replace this variable with a new variable that is numeric. So I'll just quickly run that command, and that should get our data in a format that's ready for us. Now, when we implement fixed effects in Stata, we have two approaches. Approach one is just to include dummy variables. So these would be 0 or 1 binary indicators for whatever we're interested in. So I might say, okay, I'm going to run a regression. I'm going to have my dependent variable, my independent variable, and then say, for instance, I wanted a series of year fixed effects. Well, I might include a variable that's year 1999, and another variable that's year 2000, and another variable that is year 2001. These year fixed effects would control for anything that's fixed about the year 1999, the year 2000, or the year 2001. Similarly, I could do this with a data set that was looking at states. If I said, okay, I'm going to include a dummy variable for state 1, state 2, state 3, and so forth, where each of these state variables are a 0 or 1 for whether or not state 1 is state Tennessee, state 2 is North Carolina, and so forth. Now, this, however, can become problematic when you have a fixed effect that has a lot of units. So in the ECLS dataset, we've got, I think, thousands of schools. Well, it would be impractical to create thousands of dummy variables. So instead, I'm going to use some built-in commands from Stata to set up and run my fixed effect using schools. So the first command I'll use is called xtset. So I'll type xtset, and then I'm going to give Stata the variable that I want to use for my fixed effect. In this case, it's the school2_ID, because I'm going to use a school fixed effect. So xtset simply tells Stata, okay, this is the variable that is going to be used as the fixed effect. Then I'm going to use the command xtreg. So notice this is kind of like the regress command, reg, except I've got the xt prior to the reg. Again, the format will look similar to the regress command. I'll have a dependent variable, an independent variable, and any control variables I want. And then one little addition, I'll put a comma FE to tell Stata that I want to use a fixed effect, where the FE simply stands for fixed effect. Video segment, we've briefly and quickly introduced fixed effects in Stata. We said you can either utilize fixed effects by including a series of dummy variables if you have a small number of groups that you're fixing over, or you can implement fixed effects using the xtset and xtreg commands with the comma FE at the end of that xtreg command. So hopefully this is useful to you as you begin implementing fixed effects in Stata. I thank you for your time and watching this video.